Okay, so we remove the H off the O, the H off the C. Those two H's pick up more oxygen from the permanganate ion, and they'll produce water on the other side as opposed to hydrogen gas. You now make your ketone. So the type of reaction here, because we've added oxygen, this is a controlled oxidation. Because we're not combusting it, we're slowly, under controlled conditions, adding oxygen from a permanganate source. And because we've taken these two H's and we got rid of them and we didn't replace them with anything, putting a bond in is not a replacement, is not a substitution. What we have here is an elimination. We eliminated the two H's, added a bit of water to it to make, or oxygen to it to make water on the other side. So this is an elimination. And that's number 6 finished. Okay. Number 7. So number 7 is we're going to take a ketone and we're going to turn our ketone into 2-methoxybutane. So to make our 2-methoxybutane, we need to, if we go to our pathways chart, we're starting with a ketone, and you have to know that this is an ether. So to make a ketone, we have to turn it into an alcohol first by adding hydrogen, and then we have to take that alcohol, add another alcohol to it to make the ether. So an ether is made from the reaction of two alcohols. So our parent ketone we have to start with has to be a butane, because that's the parent in our ether. So we're going to start with a butane ketone, which is butanone. So we're going to start with butanone. And what we're going to do is, according to our chart, we're going to add hydrogen. And remember, hydrogen is H bonded to an H. So what'll happen now is the H and the H are going to attack this double bond on the O. So it's the opposite of the previous reaction we did. And it's going to open up a spot on the O and a spot on the C where those two H's are going to go. So 1, 2, 3, 4. So now we'll have an O bonded to an H, and then the other H would come off the C. So now what we have is butanol or secabutanol, whatever you want to call it, and there's no other byproduct. So adding a hydrogen, remember, is a platinum catalyst, and room temperature, or sorry, not room temperature, my apologies, heat and pressure. So we have to add heat and pressure to that. And because we've added hydrogen, this is a hydrogenation. And because we've actually added two atoms that weren't there before, this is an addition reaction. So now we have our alcohol, now have our OH, to make 2-methoxybutane, knowing that it's an alcohol plus an alcohol. If we have the butanol, then what we need now is a methanol. So another rule to be aware of is when you're making an ether connection, you always remove the OH from the parent, which will always be the first alcohol that you draw, the bigger alcohol. So we're going to take this here and we're going to remove that, and then we're going to take the H off of the smaller alcohol and remove that. So we know we're going to get water on the other side because the H and the OH come together to make water. And what happens now is this open bond is where this O with its open bond connects. So we'll have our 4-carbon parent, and then this here, OC, will connect there. And there's your 2-methoxybutane. So we're going to take this methanol ditch the H from it. That opens up a bond on the O, and that will connect to this C that also has an open bond because we removed the OH. And the OH and an H were eliminated, producing water on the other side. They were not replaced with other atoms. We've actually synthesized a larger compound by doing this. So when we look at our types of reactions, we know that we have an elimination. Okay. And if you're looking, for example, at the other type of reaction that's going on there, notice, because we haven't done this yet, there's a chart. So this is where condensation comes in, a reaction in which two molecules bond to produce a single larger sized compound. So in other words, we made the organic compound larger by adding another C. In biology, you would have learned this to be dehydration synthesis. So you synthesize a larger compound by undergoing dehydration. In chemistry, we call that a condensation. So it's not a hydration because we don't have the same number of C's, excuse me, that we did with the previous ones. We've added another C group. So we've synthesized something larger. So this is a condensation reaction. Okay, and in a condensation reaction, if we go over here, when you add alcohol, it's the same thing as when you add water. You need concentrated sulfuric acid as a catalyst. So above your arrow, you're just going to put concentrated H2SO4. Okay, so we eliminated the water. And because the elimination of water, that dehydration, synthesized something larger,